Hello, in this video we will show LINEST and matrix solution of multiple logarithmic regression. This is multiple because we have two independent variables. This data set we have one independent variable and two independent variable. The equation we'll use is the logarithmic, which is y equals b0 plus b1 ln x1 plus b2 ln x2. Separating it in the matrix format, it will be 1 comma ln x1 comma ln x2 times matrix b0 semicolon b1 semicolon b2. The first matrix 1 comma ln x1 ln x2 is this matrix. The second matrix separated by semicolon will be this matrix b1 semicolon b0 semicolon b1 semicolon b2. We start with the transformation of our data set, which is array formula of the y values. Next, we complete the 1 comma ln x1 ln x comma ln x2 matrix. We start with the 1 column and the x1 column, which is array formula of the ln of the x1 and x2. Now that we have transformed the data set, we can now enter the LINEST function, which is LINEST of data y and data x, and we show the full statistics. Here we have 12 outputs. We will calculate each output of the LINEST function using the matrix solution. Start with the p-joiner inverse, which is m mult minverse m mult transpose of the 1x matrix transform matrix and itself. Then we calculate the p-joiner cofactor, which is m mult transpose of the 1 comma x matrix and the y values, the transform y values. Now we can calculate the coefficients, which is m mult of the 1x matrix and the p-joiner inverse and the p-joiner cofactor. Now that we have the coefficients, start with b0 matches to the LINEST output negative 167.16, b1 negative 16.659 matches to our LINEST output, and b2 77.38 matches to our LINEST output b2. Now that we have the coefficients, we can calculate the estimated y, or the y hat values, which is m mult of the 1 comma x matrix and the coefficients. Now that we have the estimated y and the y hat at the y values, we can now calculate the residual sum of squares, which is sum of the squares of the difference of y and y hat. 219.66 matches to our LINEST output. Next, we calculate for the number of rows, which is, or the population rows of the rows of that. So we have our population 9. So we can calculate the degree of freedom of the denominator, which is rows minus columns. Columns 6. Now I can calculate first AX, which is equal to square root of RSS divided by degrees of freedom. 6.0506 matches to our LINEST output. Next, we calculate for the standard error value of the intercept or BO, which is equal to stay x times square root of Pigerina 1, 131.5899 matches to our LINEST output. The standard error value of B1, which is again stay x times square root of Pigerina trace 2, which is 22.522 matches to our LINEST output. And the standard error value of B2, which is again stay x times square root of Pigerina trace 3, 60.79 matches to our LINEST output. Then we can calculate for the regression sum of square. We begin with the total sum of square, which is equal to the population times variance of the population y. 753.707. We can calculate the regression sum of square, which is 757 or TSS. That's the total sum square minus regression sum of squares. So it's 534.04 matches to our LINEST output. Our F statistics, first we calculate the degree of freedom numerator, which is equal to columns of the x values or the x variables. We have only two x variables, so we can calculate the F statistics, which is regression sum of square divided by degrees of freedom of numerator divided by stay x squared or stay x squared raised to the power 2. 7.29 matches to our LINEST output. Next, we calculate for the R squared, which is equal to ESS or regression sum of squares divided by total sum of squares. That's 0.70855 matches to our LINEST output. This completes the LINEST and matrix solution of multiple logarithmic regression.